So another useful metric in sort of comparing or evaluating the strength of acid is just to compute how much of it's dissociated or its percentage, which is really just a direct measure of K, because K tells us virtually the same thing, but percentages are maybe more intuitive for human minds. So at equilibrium, how much of the acid has actually broken apart, and so we call that alpha. But the definition is pretty intuitive. It's just the concentration that's broken apart divided by whatever the initial pre-equilibrium condition was. So let's just look at an example directly to apply this. So let's try to figure out what the percent dissociation alpha is for the same system HF, but at 0.050 molar. So really how much of this original 0.05, which is our initial condition, how much of it actually breaks apart. So we'll start up with an ice table. Like always, we just need to figure out if we have an initial condition set, what's our equilibrium system. So we've got 0.05, nominally 0 hydrogen ion and 0 fluoride. Some amount of X is going to dissociate, and so we'll have an equilibrium condition of 0.05 minus X. So we can do what we have been doing all along, which is then plug this into the equilibrium expression, knowing that we can just look up the Ka in the back of the book or online, and so we get something that looks like this. This will be really familiar because this is almost always the form that we're going to get at the end of an ice table. So pop that into the quadratic equation, you get x is equal to 4 times 10 to the minus 3, and if we look at the actual ice table here, x is the amount of HF that's dissociated, right? Because at equilibrium we have 0.05 minus X. So we could compute HF here, 0.05 minus this value, and that would give us the undissociated amount of HF. But we really want the dissociated, which is left over. That's the X term here. And so we're going to pop that into our dissociated amount and divide by the original, which is just 0.05, and that would give us our percent dissociation. And that gives us 8%. So our percent dissociation is 8, which just means that when we toss 0.05 molar HF into solution, only 8% of it's actually going to break apart. It also means 92% of HF remains undissociated at equilibrium. It means H and F are still bound together covalently.